Hey mathematicians, welcome to the Perth Mint, and we are doing today the Share $1 investigation, which is perfect because we are currently at Australia's oldest operating mint. So I want you to imagine that you're at the mint and you find a gold coin, $1. And so at first you're just on your own, so you get to share that dollar all with yourself, just you. So I want you to imagine that you've got $1 and you're sharing it between one person, so one shared between one gives you 100 cents. Therefore, 100%, because percent is always out of 100. That's why $1 is such a good context for percent, because it's 100 cents, 100%. Or it gives you 1 as a decimal, which can be written a lot of different ways. And that's the first day. But the next day, you drop on by the mint again, and you find another $1, but you are with your best mate. So instead of losing a mate, you decide to split the $1 fairly. And for that, you work out that you each get 50 cents. So $1 shared between two people gives you half the money each, or 1 out of 2 parts of the money, which is 50 cents. Therefore, 50%. And therefore 0.50, 0.5, because it's 5 of the tenths, 5 of the 10 senses, and so on. So the next day is a really gnarly one. You find another $1, and you're starting to see the pattern here. But unfortunately, as well as being with your best mate, which is great, your little sister tags along. And now little sis says, no, I need a share of that. It's got to be a fair share. And you just go, okay, it's not worth it. Let's just split it evenly with her and get this over with. So you decide you need to share that out. That's a bit harder. So you decide to use some coins to help you figure it out. It can't be done in just one step. So you might grab 20 senses from mum and you rename the $1 into 5 20 senses, but you've still got 2 20 senses left. They can't be given just to 2 people because she's going to crack it. So you then go to 10 cents mode potentially, and you go 4 10 senses and you share those out. Again, we have a problem. And at this point, we need to imagine, because Australia doesn't have single senses in currency, but we do have it in what we pay for things. We pay single cents amounts all the time. We pay 99 cents, $19.99. So single cents still exist. It's just that we don't have them in currency. So we give out 9 of them, but we've still got 1 single cent left, or one of these. That one's already been worked on by a few students. So then what the students often do is they'll arrange the characters around that $1, and then they'll split it into thirds, like so. We often use the capital Y trick. So when you split into thirds, excuse my joltiness here, like that. Or imagining a wind turbine, because they're often in thirds. And then you figure out what each of you got, which ends up being 33 cents and a third, or $1, shared between 3 people, is the same as saying 1/3 of the money, or 1 out of 3 shares of the money. So 33 cents and a third, but I'm just going to go rough here. I'm not going to be too fussed about precise answers, because I'm using this more as a computational tool for mental working out of answers. I don't really need the 0.3. It's just going to be a rough type of strategy for mental answers. So roughly 33 cents, so 33%. The next day is a little bit nicer, and you don't expect it to be, but it is, because you find another $1. You're really in the luck here. The Botanical Gardens used to hide dollars back in the day, and my dad always used to take us because he always valued the coin in terms of, he grew up quite poor in Collingwood, so $1 used to be worth a fair lot. And also we just had a heap of fun trying to find dollars and $2 coins that had been hidden by the garden staff. So that was awesome. So you can imagine you're on one of those Botanical Garden hunts from back in the day, and you find $1, but you're now with 4 mates. And so this sounds gnarly at first, but actually it's not too bad, because if we make 5 20 senses, and excuse my pause, my 20 cents as we're hidden under my counters. So 5 20 cents, and then we can give 1 20 cents to each of you, and we've renamed the dollars into 20 cents, or the dollar, but we've got a problem with that 20 cents. If we rename that 20 cents into 4 5 cents, then we can give each of those out, and that 20 cents has been renamed into 4 5s, and we can see the answer straight away from there. So $1 shared between 4 people gives everyone a quarter of the money, which means everyone gets 25 cents, therefore 25%, and therefore if it was written in dollars, 0.25, often with a dollar sign at the front, but 0.25 is fine. I'll just write 0.5 there as well, and the percentage. So you can keep going pretty much on that task, and you do, you're with 5 mates, you're with 6 mates, 7 mates, 8 mates. We often go to 12 or 16 mates or 20 mates even, to get all the percentages up to a 20th, which is a nice one. But there's also a way to do it with patterns. So let's say instead you start to talk with the students about a more efficient way to do it than having to go one by one. Because if you talk about numbers live in families, then once we solved the $1 shared between 2 was 50 cents or 50%. And then we can write the decimal, but I'll leave that off for now. Then, and then therefore the half, but I will write that because that's quite important, because that's really the purpose of the task, knowing that the half is 50%. And I'll write it in, the 0.5. Well, then what else lives in the 2's family? What is related to 2 in maths? So 2 is related to 4. So if we know sharing between 2 is 50 cents, we know that 4 people will then each get half of what they would have if they were sharing between 2, because now you've got 4 people, so everyone gets half of what they would have had. So therefore it's 25 cents, 25%, and 0.25. And then what's related to 2 and 4? 2 and 4 is in the same family as 8. So if we know the quarter and we know the half, we also know the eighth is then half of this. So 12.5 cents or 12.5% or 0.125. Likewise, we could do 16 and so on. But if we know 1 shared between 3 is 33 cents, 33%, and 0.33, then we also know what? What else is related to our 3 in our maths families? So related to our 3s is 6. We can just half that again, and it's 16.5, roughly. I know that's not exact, but for mental computation and figuring out percentages of things, it's often close enough. And 0.165. I know it's 66, but roughly. Now, 9's an interesting one, because you could just, if you know 3, well, you're dividing that by 3 to get to 9, because 1/3, if you're sharing between 9 people, everyone gets 1/3 of what they would have got if they were sharing between 3. Or you can think, well, 100's really ugly to split between 9, but you know what's not ugly? What's close to 100 that splits between 9 really nicely? 99 cents, yeah? So if I think 99 cents shared between 9 is just 11 cents, and therefore 11% and 0.11. So then we get most of them. You can do tenths and fifths as well. And the only one you really need to work out by logic is sevenths. Sevenths is an interesting one, because if you know eighths and if you know sixths, then sevenths pretty much lives in between them, and it's roughly 14%. So often for my sevenths, to help me remember it, I just know that I know my sixths, I know my eighths, so I just go in the center of those, roughly 14%. That's so helpful for a lot of computation later, and also the Think $1 really helps. If I give you like 4/5, an anchor chart's not really going to help, because you probably haven't remembered what 4/5 is. But if I say think $1, share it between 5 mates. $1 between 5 mates gives you 20 cents. So now you get 4 out of 5 parts of that dollar. So instead of 1 cents, you get 4 20-centses. So that becomes 80 cents, 80%, 0.8 or 0.80. So suddenly we've got this way of converting that's not based on an anchor chart or memory. It's based on a strategy of think a dollar, because a dollar is 100 cents and per cent is out of 100, and decimals are so related to base 10. So it all connects beautifully, but we've got this physical tool and a manipulative of how to do that. One other thing I want to show is how we can also use it for a lot of fraction work. One example is we're comparing two really gnarly fractions, like not ones that are just easy to use, rectangle model or circle model to compare. Let's say it's 4/7 and 5/11. Which one's bigger? So there's another strategy for this, but if you've already figured it out, hold off. I'm going to explain that soon. But if we were using percentages rather than just like denominator, which is a high school process that is often quite inefficient, or it's just process-based, but there's no real understanding. If instead we were thinking a dollar shared between 11, well, that's too hard. 100 cents, no thank you. But 99 cents shared between 11, what's 99 shared between 11? 9 cents. So then 5 nines, 45%. And then 4/7, well, we just realized that 7ths is 14 because 8ths is 12-ish and 6ths is 16, so roughly 14%. So then 4 groups of 14, well, we know 40, and then 4 groups of 4, 56, so 56%. So we can convert them to percentages, we convert them to decimals, because once you've got the percentage, the decimal's pretty straightforward. The percentage is the hard part from the fraction, and we know that this one's bigger. But there was a better way, and better than the high school procedure of just like denominator, and that is that which one's more than half, which one's less than half? So which one of these is more than half? And which one's less than half? Because if there's one that's less, one that's more, we can just go reference to half. That one's less than half and that one's more than half, so this one is definitely the one. And this would be more of a check-in mechanism or a proof mechanism. But once you've got more than less than half, you really have proven it already. So there are other strategies. High school textbooks, in my opinion, often teach one of the least efficient strategies out there and the less conceptual strategy, whereas this share $1 for me changed the game, even as an adult, for getting to percentages from fractions. I just thought a dollar every time, shared it between how many mates, which is your denominator, and then multiplied that by how much of the dollar I was getting, the numerator.